Engineering Department, LE-Morbi. We'll wait till sir joins. I think sir has joined. Yes, we welcome you, sir. Welcome you, sir. Madam. Yes, sir. It's my pleasure to introduce Dr. R.K. Mewada, Professor and Head Chemical Engineering Department, LE College of Morbi. Dr. Mewada has PhD in Chemical Engineering from UICT, that is University Institute of Chemical Technology, Mumbai, Matunga. Sir did his ME in Chemical Engineering, Petrochemical Engineering from Faculty of Technology and Engineering, MS University, Baroda, and B from GEC, Gandhinagar. Dr. Mewada is currently working as a Professor and Head Chemical Engineering Department, LE College, Morbi, Gujarat. Sir was also Professor at Chemical Engineering Department, Nirma University from 2015 to 18. He has also served as Associate Professor and PG Coordinator, Assistant Professor and Lecturer at Nirma University, Ahmedabad. Dr. Mewada has 2 patents to his credit. He published 1 book and papers in several national and international journals. Sir guided 15 ME students, 4 PhD students, and delivered 24 expert talks. He is also involved in 2 consultancy projects. His papers are in international journals with H index 10, I-10 index 10, and total citations 5,821. I request Dr. Mewada to please take the charge of session and share his experience with all of us.
Thank you, madam. My voice is audible?
Yes, sir.
Thank you very much. I hope participants will enjoy and learn something. I'm going to share my experience, which I have carried out some small project work at NIRMA, and that's what I thought to share with all of you. I'm going to share PPT. Please let me know is it visible. It's visible to screen. I've shared PPT.
Yes, yes. Okay. Visible.
Fine, thank you. So, very good afternoon. Very good afternoon to all the participants. So we are going to discuss about, yes. So we are going to discuss about hydrogen as a future fuel. So definitely topic is very interesting, and this when sir has asked, sir and madam has approached for a lecture and topic, I was thinking which topic should be a better one. So with reference to the title of the STTP, the role of green chemical technology in sustainable development. So I thought let me share this small piece of knowledge which I have worked on as a small project work. So basically, we all are facing certain problems, definitely in terms of energy, in terms of another pollutions, fine. So hydrogen may be a solution in that aspect, and as well as definitely we talk about the sustainability. So if we can produce hydrogen from material which is plenty available in on the earth, then definitely it will be a good idea. So that's what I thought and I think to share with you. So contents which I'm going to present today briefly different problems and limitations of the current system, and definitely tentative possible solutions and crisis and solutions, and with reference to ultimately hydrogen production methodologies which I'm going to share with you. So challenges, definitely we all are facing these ecological, economical and environmental problems. So in a broader prospect, we are all aware that vehicular emissions means emissions which are coming out from the different vehicles, maybe two-wheeler, four-wheeler, etc. Fine, whatever the fuel source, maybe a petrol, maybe a diesel, even CNG to some extent. Fine, it creates it contributes even probably the largest amount of pollution. Definitely, And second issue is that it is a moving, it's a mobile, fine. So that's why to tap it, it's a very difficult task. Industrial gases is also another definitely source of environmental pollution, fine. But again, this is with reference to this air pollution we are talking about. So all the major metro cities, fine, even including Ahmedabad, we have a severe air pollution level. If you look at it, the air qualities uh, data published by the CPCB or GPCB, that it's really very shared, and definitely it's alarming at the same time. So contribution of vehicle emissions in a global warming is another definitely big challenge, and all the countries, fine, including India, we're trying to reduce carbon footprint, fine, and people are thinking even to go for such fuel which can reduce not only the emission issues but also produces green uh, are better for the environment. And definitely cost wise, we look at it, prices of fuel is going like rocket prices extremely high. We don't know where we will stop this, so how much we can pay over the period of time, and we have seen drastic change in the prices. Different scenarios are there definitely, but still we have to accept that the prices are going to continue to rise, and that's why the different competitive technologies may come forward. Limitations in terms of production and availability from the natural resource point of view. So definitely crude oil as a natural resource, naturally available, we can't synthesis in the laboratory, and it is available in a very limited geographical location. Fine, OPEC are the countries who are producing and ultimately controlling the over prices. So supply demand ratio always leads to more demand, that is expected, fine, and that is the reason that cost is going to be increased definitely, except last year where lockdown was there and all of a sudden crude oil prices were come down, but otherwise definitely it is always going to be a means more going to be more costlier. Energy crisis, definitely demand of energy, and India being the developing country, definitely developed countries, their demands are stabilized, but in India anywhere we are saying that we are going to become a developed country. So one of the GDP parameters is energy consumptions or consumption patterns. So it is likely to be increased tremendously, fine, whatever we have current energy consumption level, it is expected that we are going to have a much large utilization in coming future. So in that also, in both the way, definitely energy required for the industrial applications and definitely energy required for the even transportation vehicles. That is also going to be a huge in terms of demands. Fine. So that's why again from that point of view, we are expecting that energy crisis is going to be there, and we need to find out some solution. And in terms of definitely the solution which can support environment, economics, and again ecological, that's what we are looking for. So how we can, which are the various possible solutions, how best we can look forward. So definitely like people are talking about electrical vehicles, that is all definitely one of the best option available, and to some extent it has been applied and being used nowadays, fine. Few electric cars, electric vehicles are available on the road, and it is a successful technology definitely. But right now today I'm going to discuss about hydrogen as a promising future fuel, fine. So definitely we know that hydrogen, when it burns, it gives the ultimately only water. H2 plus O2 gives, there are different technologies available. We can produce energy from hydrogen through fuel cell or by combustion, fine. But ultimately, when we produce H2, when we combine H2 plus O2, it gives a tremendous amount of energy, and that energy we need to utilize. Fine, but the thing is that how we can produce, because ultimately we are looking for hydrogen from water only. Fine. So the method which I'm going to propose, which is going to be sustainable, that's what it's our objective is also. Fine. So the technology, whatever we propose, fine, it should be sustainable. Sustainable, which means it should be good for us as well as for our future generations. So from that point of view, which fuel, how we can get the hydrogen? Fine. So that is the biggest question. Okay, how we can get hydrogen? Hydrogen is good, definitely. To hydrogen utilization as a fuel for a vehicular purpose, vehicle energy purpose, that is good. But how we can get this hydrogen? The amount of hydrogen we required, fine, and different challenges that at the end of PPT I've added a small portion and one slide that is regarding the storage and transportation. That is another, definitely that is another big difficulty. But right now we are the major focuses on the production aspects. So if we look at it, the current technologies which are available right now, so basically nowadays our common production technologies involves syngas production, that is either from the naphtha or any other crude based raw material. We can produce carbon monoxide plus hydrogen. Fine, even coal gives us syngas. We can produce synthesis, fine. But ultimately, hydrogen comes from any either crude oil or coal-based oil, coal-based as a raw material, which is going to be much costlier. Second option available, that means hydrogen produces current nowadays in a refinery, that is through the ability extreme. So whenever there is a reforming reaction, not steam reforming, regular reforming reactions where we are going to convert the alkanes linear to the aromatic chains in the terms of benzene, toluene, and xylenes, which also produces a small amount of hydrogen and few other sources of hydrogen production, that is the dehydrogenation reactions. But if you look at it right now, none of the refinery I'm trying to compare with the sulfur case. In the previous days, we used to produce sulfur through the earth crust. Fine, we get the sulfur in the terms of sulfur ores, and we used to process and we get a pure sulfur, which is required raw material for the sulfuric acid production. But nowadays, practically we can say all the sulfur is coming from the refinery. Fine, whatever sulfur we required for the different application, not only for H2S super production, but for the different applications and polymerizations, etc. Fine. So they are utilizing, that is a major source of sulfur is now refinery. How it comes from? So ultimately, all the refineries need to reduce the sulfur content of the various products. Fine. Maybe a petrol, maybe a diesel, maybe kerosene, or any other products. Because sulfur contains reduce substantially. That's why all the refineries has to remove sulfur. And so that's why they convert all the sulfur molecules into H2S, and again through Claus process they reduce it to the elemental sulfur, and that sulfur is available as a major source of raw material for the different applications. So can we expect the same scenario for the hydrogen? Can the refinery produce hydrogen which can be an excess, can be used as a fuel for the different applications? Probably not. Fine. Fine. So that is not possible. Why it is not possible? So if you look at it, I have mentioned that all the refineries has to treat the sulfur nowadays. Fine, because as per the new government laws, fine, now we have BS standard 6. And similarly, European countries, all other European standards, they are continuously reducing. If you look at it, the fuel composition requirement, then the sulfur content is reduced substantially. Fine, if you look at it in 1990s, where we have almost around 5%, and we 50 ppm, then 10 ppm, and we are trying to reduce. And it is expected that, like for example, in diesel fuel, fine, we are expecting that it should be sulfur free ideally. Fine. So if we want to make it sulfur free, we need the technologies which can remove the sulfur completely. Fine, it's a technological point of view, it is a big challenge. Fine. So I'm talking in that sense. So refineries need again hydrogen, because all the desulfurization technology, if you look at it, they involves ultimately hydrogenation. Fine. So deep desulfurization technologies, whatever it may be for any of the product, ultimately it involves hydrogen. So that's why refinery demand for hydrogen is also increasing for this particular applications, specifically for the desulfurization technologies. So in that sense also, hydrogen availability with the refinery is not in excess. Refinery does not have any excess hydrogen, rather even they need to produce specifically hydrogen for that specific application. So that's why whatever hydrogen is produced either in the form of reforming operations or dehydrogenation operations, they are being routed or being utilized within the refinery for all the desulfurization technologies. And that's why we can't expect that hydrogen may be excess available with the refinery and we can use it. Fine. Second aspect, can we produce hydrogen from the syngas either from the coal or from the CNG or any other source of raw material? Probably not. Like if simple logic is that if I try to produce hydrogen by reforming of the naphtha or natural gases, if we compare the price, the hydrogen produced from the CNG or natural gas rather, then what is the cost of CNG available and what is the cost of hydrogen if I'm going to produce it? And ultimately, my purpose is both are same. I need to compress it, fine, and I need to put it in a cylinder and I have to utilize it. So again, economical point of view, probably none of the technology maybe give us economically favorable hydrogen production which we can use for the specific purpose of as a fuel. So from this aspect, we are not expecting right now that any raw material which is coming from the either crude oil or from the coal base or some other sources which can utilize or which we can use it to produce hydrogen. And at the same time, whatever the energy required, again, that is coming from either the coal or from the other sources, which is ultimately related to the crude oil. So that's why both these aspects are tricky, and definitely we need to think how we can produce it. So ultimately, answer comes. So how we are going to produce hydrogen? What are the sources of hydrogen which can make us our future really green? Fine. So we need to look forward. Again, we are saying that hydrogen and oxygen produces water. So same water can be utilized as a source of raw material to produce hydrogen. Definitely, it is a big challenge. Fine. So hydrogen from water using a renewable or alternate energy. Definitely, I have mentioned that when we combine hydrogen and oxygen, it produces large amount of energy. When you make it reverse way, so when you try to break hydrogen means water molecule, it requires large amount of energy. Fine. When we combine both molecule and it produces large amount of energy. So when we break that molecule, water, that needs large amount of energy. So that's why again, that's why this reaction is not new. Fine. There is nothing new in it. It is a very old known reaction. Fine. But still, because of the economically it is not favorable, and that's why we are not able to use it. Even nowadays also not a single technology is available where we can produce hydrogen from water economically favorable conditions. And it is still not available. Yes, we are talking about as the prices of crude oil or prices of a petrol or a diesel or any other fuel is increasing, we are expecting that new technologies may help us. And at the same time, other incentives of reducing the carbon footprints and other advantages of environmental pollutions may give a more concern to the hydrogen production. So with this aspects, just we are going to start for that thing. So hydrogen generation from H2 without using hydrocarbon or crude oil based energy. So we are expecting that we need to produce hydrogen ultimately from water, and that too not using a conventional energy source. We must have to use energy source which are either renewable or we can have a cheaply available. Fine. So various major technologies point of view, if you look at it, the electrolysis is a very well-known process. Fine. From years together, we know that yes, we can produce hydrogen by electrochemical reaction by splitting the water to electrochemical route, and we can produce hydrogen. Second is the redox reaction. That's what I'm going to discuss. And again, thermochemical cycles are a part of redox reactions, and that's what how this whole project has started. Fine. So briefly, just I mentioned here that none of the technology still. Fine. Definitely, I mentioned that electrical vehicles are fact and it is being available and being used on the road nowadays. Today also there are electric vehicles available. Definitely there are challenges, but at the same time, similarly, there is no hydrogen car still. And definitely for few experiment purposes, only few experimental purpose is being used, otherwise commercially is not available. So that's why definitely this is a case where we are expecting that maybe down the line, after down the line 10 years or 15 years, we are expecting that we may have a hydrogen as a fuel. So that's why I've used this word. None of the technology yet proved to be economically fine, and yet different stages of research, different institutes or different researchers are involved in this very high profile research, we can say, or very interested to the industry as well as to the from the social point of view. We are expecting that we may come up with some better technology which can economically as well as environmentally we can produce hydrogen which can use for a fuel purpose. Fine. So just a common slide that hydrogen can be produced through electrochemical route, fine, electrolysis, where we are using energy to split this water or split hydrogen and oxygen, that is using a solar energy, fine, or it can be definitely nuclear energy, fine, wherever it is possible, fine. But after the incident in Japan, because of after tsunami, whatever the leakages occurred in nuclear reactors, and that's why Japan, which was one of the means, Japan was one of the major user of nuclear energy. Definitely, Germany is there. But because of that, after that incident, they decided to shut down all the nuclear reactors, and they look forward for some alternate energy sources. And just I was yesterday I was going through one news that because Japan is such a geographically located, they cannot, and that size in terms of their area availability is very small, so they cannot use like a solar energy or something. So that's why they are also expecting that if they want to reduce their carbon footprint, fine, because they are a developed country and their utilization of energy is very high, so they need a large amount of energy, and so they are expecting hydrogen as a energy source, as a fuel that they are ready to import. Definitely they are changing their national policy accordingly, and maybe down the line 2030 40 they want to reduce their conventional energy source substantially, and they want to replace it with a better or green methodology like a hydrogen, fine. So one of the source of hydrogen production that may come through the water electrolysis, water splitting through the electrolysis. And again, I'm saying that the energy which is being used, otherwise definitely this is a highly energy intensive process. It consumes a large amount of energy, fine. And we are expecting that it can be only possible through if we have a substantially lesser cost of solar energy comes in a picture. Definitely in the last 5 years we can see that there is a substantial reduction in terms of solar energy, fine. And government is also promoting like a rooftop schemes we have seen, fine. Many of houses are available, many farmers are installing the solar PV cells in their farm. So similarly we are expecting that if further cost, if this PV cell technology cost is reduced further, then and it can be successfully utilized for the electrolysis process. Definitely pros and cons are there. We are not going in much details. I'm going for some other aspects. So again, and research is going on for the reduction in the cost in the different aspects. So energy integration either with solar or a wind or a nuclear can be there. So research focuses on the overcoming the challenges, reducing the capital cost of the electrolyzers. Definitely one of the major cost is there, and the balance of the system, the improving the energy efficiency for converting electricity to the hydrogen, and integrating compression into the electrolyzer to avoid the cost of separate hydrogen compressor. This is just a research aspect. What I am interested and where I have started this thought. So almost in 2009, after completion of my PhD, just I was thinking when one of the project at that time when I was there in university, one of the project of copper chlorine cycle was started, sponsored by the ONGC in under my guide's research group. So I was thinking, can we have like we have a battery? When we are all using a mobile phone and we have a battery which we are charging and discharging. And so after charging, we are using it for throughout the day, and it gets a discharge, and we recharge again. Can we do the same energy? Because ultimately, I want to utilize chemical energy. So can we do same thing with in terms of chemical energy? Definitely, petrol and diesel is why it is better as a fuel, because its energy density is very high. Fine, we can have a large amount of energy with a small volume. Fine, so can I have such a chemical battery which produces, ultimately can I utilize energy, and that through natural resources? So that through literature, so I come to know that this redox reactions. Fine, it's a very easy to understand, a very simple concept is that, like we can have a reduction of any metal oxides. Here just I've given an example. Zinc oxide, if I carry out its reduction, if I remove the oxygen from a zinc, fine, it produces pure zinc and oxygen. But and again, this zinc is, if we add hydro means water, if we carry out hydrolysis of zinc, again zinc oxidation is being carried out in presence of moisture or in presence of steam, then it produces zinc oxide again and produces H2 as a one molecule. So now if you look at it, so this zinc oxide, I have regained it again. Fine. So after oxidation of zinc, I'm getting zinc oxide. If that zinc oxide is being reduced at a high temperature, it is converted to zinc and it produces oxygen. But the thing is that, like zinc uh, oxidation is very easy at almost 400 degrees centigrade. I can carry out a zinc to zinc oxide reaction at a 400 degrees centigrade reasonably means less, definitely high temperature, but is reasonably achievable, we can say. Fine. But reduction of zinc oxide, fine, which is taking place almost at 2000 degrees centigrade. So that is extremely high. Fine. So from concept point of view, from the theoretical understanding point of view, this looks very nice. Fine. That is a very fantastic reaction. Fine. And I can carry out a reduction of zinc oxide, and I can remove the oxygen very easily, but provided at 2000 degrees centigrade. And the same zinc I can reoxidize again at a 400 degrees centigrade, and I'm going to produce I'm going to produce hydrogen. So this hydrogen is the chemical energy which also here the whatever the temperature and energy required. Fine. So we are supplying a energy required at high temperature, and we are gaining that energy in terms of hydrogen as a chemical, and we are going to store this energy. So this is very simple reactions. This is a very interesting reaction. Only the problem is now how to achieve this, because to achieve 2000 degrees centigrade is impossible practically. Fine. So definitely I like it very much. I have worked in a different way. I've carried out a different literature survey. Then I come to know what are the problems and how. So one of the solution, definitely we can think of it, how we can achieve this high temperature. So again, our condition is that we are not supposed to use any conventional energy source. Fine. I am not supposed to use any conventional power, electricity available. If I have to use at all, I have to use either solar energy or wind energy. Fine. Even we are not opting for the nuclear energy. In it is not possible. So only option we have available is solar energy. So can we go for it? So yes, theoretically, let us see how we can do that. So success of redox reactions depends on how efficiently we can achieve the required high temperature, that is around 2000 degrees centigrade. Definitely, this is one of the example I've given. There are different metal oxides which can be reduced at a different temperature. Fine, but definitely most of the metal oxides which are being used or can be utilized, they requires even much higher temperature than 2000 degrees centigrade. So that's why I will just put an example over here. So yes, I have tried with the different point focus solar collectors. If you check it out, there are different types of solar collectors available, from starting from flat surface, which conventionally we are using either for the as a solar cooker or a solar heater to increase the temperature of water. Fine, but that's temperature rise in a flat type is hardly we can get it maybe around 80-90 degrees centigrade, or if it is a evacuated tube, it may be around 200 degrees centigrade max. Right? If we go for point focus solar collectors, further we can have a high temperature almost in the range of 400 degrees centigrade. Fine. And depends on the different scenario. Like a point focus solar collector is like a magnifying glass. Fine. We used to have that. magnifying glass during our school days, and we used to light up. We used to burn the paper or wood using a magnifying glass. So same application, but at much larger scale we can have it. And second option is the use of a Fresnel lens, which is also like a magnifying glass, but it has a much better design. So we can go for it, and I have tried to use that, and can achieve almost 100 to 1000 degrees centigrade. But still, the challenge of attaining or getting it 2000 degrees centigrade is not an easy task. So just for understanding, might have come across, this is a design of Fresnel lens. This looks like something like this, where concentric lines are there, and again it works like a point focus. We can get, so we are going to get a point focus or very high temperature at the focal point. So this is what is the setup which I have prepared. Now I'm going to come to discuss the different aspects. So just for your understanding. So this is what is the central portion, like this is a Fresnel lens, right? And I try to track it both in a like a dual axis tracking system I try to design. And again, I use a solar panel ultimately to track and to move it. So ultimately, I try to make it in such a way that ultimately depends only on the solar energy when to move this and to collect, and through this I'm going to collect the solar energy at the focal point of it. And with this I could achieve almost, definitely devising is another, but almost around 100 to 1000 degrees centigrade I could achieve. I have carried out certain reactions which are taking place almost at 1000 degrees centigrade. That's why I'm putting it here as a, I could achieve around 1000 degrees centigrade. But this is for the instantaneous or for momentary purpose. When we use it for continuous basis, it was not able to reach it. So in this redox reaction, one of the major limitation comes is we cannot achieve 2000 degrees centigrade. Fine. Any other reactions, if you look at it with any other metal oxides, but this is what is the lowest temperature which we found in the literature survey. So it is impossible. Fine. If I could not find any other, like definitely we can further focus and all other things, but achieving 2000 degrees centigrade is a big challenge. Fine. So even though it seems very interesting and theoretically looks possible, but practically it is not possible to achieve it. So that's why now what is the research is going on. So again, I'm coming to the main point where thermochemical cycle comes in the picture. Thermochemical cycle, again, it works on the same concept that we are going to utilize, there are different chemicals involved in the whole cycle, and ultimately only consumption of water is taking place, which produces hydrogen and oxygen, and rest of all the chemicals are being recycled on continuous basis. Right? So this is the whole concept of thermochemical cycle. What is the reason that I mentioned the zinc oxide redox reaction? Fine, reduction of zinc and again oxidation of zinc. It's a wonderful cycle, only two-step cycle, but it requires very high temperature. And that's why if I want to ultimately, I want to make it success, what I need to reduce this temperature. So we must be able to think something else in such a way that can I reduce this temperature, which is going to be a practical or which is achievable. Fine. So that's why there are almost more than 300 different cycles are proposed, right? 300 different cycles theoretically available in a literature survey where we can, but most promisingly where different researchers are working, fine, throughout the world, they are the major few cycles are the sulfur based, like a sulfur iodine cycle, the copper chlorine cycle, iron chlorine cycles, cerium chlorine cycles, and vanadium chlorine cycles. So ultimately, why we are going for this? These are all multi-stage processes. So where it involves even like I need to use hazardous chemicals, I need to use hazardous situation, I need to handle hazardous situation. But only the thing is that definitely theoretically we are expecting that all the chemicals, even hazardous chemicals, we need to recycle it. They are completely recovered within the process, and we are going to recycle it, and only consuming element or consuming molecule is the water. Fine. So with this concept, these are the various cycles available are being research is going on for the different at different institutes by different researchers. Fine. And ultimately, why we are going for this? So ultimately, because I need to reduce the temperature, which is much below maybe 1000 degrees centigrade. Fine. So here that is most of this, all the cycles are having a highest temperature around 850 degrees centigrade. Fine. All have a different maximum temperature. Fine. Out of this, I've decided to work on the copper chlorine cycle, in which I'm going to discuss now. Fine. So what literature survey? Definitely this whole project I have carried out. I mentioned that like somewhere in 2012 onwards, I started working, and I got financial support from Good Coast in 2014 to 16, and one more minor project I did for the same purpose is from the name my university itself. Fine. So this is a piece of work which my students have worked on that. Masters students as well as undergraduate students have supported me and helped me in this project work. Fine. So as per the literature survey, copper chlorine thermochemical cycle is a series of chemical reactions and having lowest operating temperature. Fine. How lowest? That will come to know. I will discuss that. Fine. So out of all the cycles, definitely copper chlorine was found to be having lowest temperature, highest temperature requirements around 540 degree or 550 degree centigrade. That is the highest temperature in whole cycle, which is practically achievable. That's why we need to, and that is the most important thing in the all thermochemical cycle. Copper chlorine thermochemical cycle is common to metal uses like water, definitely copper chlorine, CuCl2, HCl, and copper, definitely. So this HCl is going to be definitely hazardous. Intermediate products are recyclable, and in closed loop, only water is required to generate heat in a process step. Fine. So ultimately, only water is being consumed. Rest of all the chemicals, fine, whatever chemicals we have seen, and we'll see that they are recycled, ultimately recovered and recycled completely. That is what we are assuming. Definitely, when we go for practical, maybe some losses we have to expect. No any type of greenhouse gases emissions theoretically, definitely, because we are consuming only water. No other gases are eliminated or remove going out from the process, and that's why no other greenhouse gas emissions. And there are different steps: 5-step process, 4-step process, or 3-step process. Definitely, as we reduce the steps, higher temperature, highest temperature is increases. So in my case, I've chosen the 5-step process. Definitely some challenges. It's the reactor design and fabrication was a very crucial aspects. Material of construction is another challenge. Solar energy as a heat source, how we can achieve it. Right now, definitely I'm not going to discuss much all the things about in the results, but just we'll see overview. So, so material of construction is another challenge. Solar energy, how we can utilize. I'm going to discuss that. How the setup which I've shown about Princeton, that was the and when I almost ended the project. At that time, I could achieve it, but before that, I have faced lots of other problems also. So that's I'm going to discuss briefly. So, and combining the thermochemical cycle with the solar energy is one of the several processes to produce hydrogen. Solar concentrators can be linked with the copper chlorine cycle, and Princeton lens is one of the options available. Why I choose the copper chlorine cycle? That is because it involves maximum 530 degrees centigrade. My highest temperature in the whole cycle is maximum 530 degrees centigrade. Then the intermediate chemicals are relatively safer and inexpensive. Definitely, relatively, we are talking about. Right? Like sulfur iodine cycle. So we handling sulfur and iodine is more corrosive and more difficult in that sense. Reactant and products are commonly and easily available. All the chemicals available easily. Only water is being consumed, that I already mentioned. With appropriate steps, lab solid handling is necessary. Definitely throughout the process, somewhere only like a copper comes in a picture. So solid handling, and definitely citric oxide, which produces the intermediate product, that is comes as a solid handling, because handling a solid is the most crucial aspects. Fine. Energy efficiency point of view, thermal efficiency of the cycle is around 44%, and it can increase up to 49% compared to the other cycle. And find reduce the greenhouse gas effect, environmental friendly and clean system, provided we can recycle all the chemicals, we can recover all the intermediate chemicals. Fine. Then only then definitely So with this expectation, definitely this technology, this is, I'm not saying this is a success story, definitely it is a failure story, because I have learned many things, but ultimately we could not produce the final product economically. And that's why, but still I'm sharing this because we have learned something from this. So what is, now let us be, which are the various steps involved in this copper chlorine cycle, thermochemical cycle. Fine. So first step, let me put whole slide, then it is better. So this is how the whole picture is going to look like. If you look at it in the whole process, ultimately everything is being recycled, fine, except this H2O. So in the whole process, only consuming element or consuming molecule is water, and ultimately we are producing hydrogen as output, definitely hydrogen and oxygen. Otherwise, rest of all the chemicals are being recycled and reused throughout the whole cycle. And so that is a definitely striking feature of the whole process. So like if you start, for example, we have a copper chloride CuCl2, and if we carry out hydrolysis in presence of steam, definitely it produces a copper oxides. It's an intermediate product. It maybe needs decomposed. Fine, this is a solid product. Need to be decomposed again at high temperature, which produces oxygen and copper chlorine, and it need to be electrolyzed. Electrolysis process, I need to produce ultimately copper. This copper again utilized for the uh, to produce hydrogen with the carrying out a reaction with HCl. Fine. So this copper is recycled to this process where it produces UCl again, and this UCl is again sent it to the electrolysis process where we produce again UCl2, and this UCl2, fine, because of it is a electrolysis process, water is present there, we remove the water content and it needs to be again recycled. The first process where we again carry out hydrolysis of copper chloride. So this is how all the compounds or the molecules which we are using, fine, they are recycled back and reutilized throughout the cycle except one molecule, that is water. So we can say that only one raw material is entering in the process, that is externally, that is water, and we get hydrogen and oxygen as output, as our desired product. Fine. So this is again very fantastic, very interesting reaction, definitely, but very complicated also in nature. It's a multi-stage process. Find various temperatures which are required are mentioned over here. So I mentioned that the maximum temperature is that's around 530, 540 degrees centigrade. Fine. So this is a 5-step process, and these are the different chemical reactions which are taking place at the different stages. Fine. Definitely this is a solid product, is solid. You need to, because whenever solid comes in a picture, you can think of it how we can remove these products, fine, in the from the reaction mixture. Electrolysis process, hydrogen production, which is the main reaction, fine, and drying processes. So these are the different temperatures involved for each steps, fine. And now the definitely this is a big challenge. I mentioned that this experiments we have carried out in our in my university laboratory, and fine, definitely we have almost we have done with the scrap, almost everything we have designed, whatever we required. So this I'm sharing as just small story to how we handle all this different difficulties and how we solve, how we try to solve it. Experimental setup, definitely I mentioned that we need to ultimately produce all the compounds, fine, and ultimately final desired output is expected that all the reactions need to be carried out using the solar energy. But to have to build up the confidence, definitely when we start this project, right, along with my undergraduate and postgraduate students, so we need to thought first with what we are going to get it, fine. So first of all, we carried out all the reactions using conventional energy. Again I repeat, we carried out using all conventional energy like electricity, and we have, these are the various steps involved. And this, if you can see, all the uh, whatever we require, we have designed ourselves and we fabricate it. Fine, definitely gets fabricated through the outside fabricator, but again we design and we carried out all the reactions in a laboratory, all the different steps. I'm not going to discuss in details, but these are the various steps, and then later on we link it to the solar energy. Fine, so this is for this demonstration purpose how this hydrolysis reactions were carried out. So again, what you can see here, this is a wonderful glass column which we have gets fabricated, trying to again remove whatever, like we have HCl reactions comes in a picture, so we need to remove excess amount of whatever unreacted HCl comes out, or sometimes other gases, maybe unreacted gases comes out, that we need to remove and need to absorb. Definitely, in the special cases, we have designed this ceramic lined reactor, small, very small volume, fine, but to check it, how the material of construction affects. So one of the results I will show you. I have put this slides just to have a feel that is how we worked with this. So this is how what happens, because it's a final hydrolysis, final product is a solid, definitely, and it's again corrosive in nature. Decomposition steps. This is the highest temperature which we required in the process, 530 degrees centigrade. Definitely, this is with the conventional energy, and then we replace it with the solar energy. Electrolysis process, where copper depositions takes place, because ultimately electrolysis use here, we are going to get the copper as a one of the solid product. So I mentioned that we have carried out all these steps with using conventional energy, fine, just to make sure that yes, to build up the confidence, okay, whatever steps we are following, at least it produces the desired product. Now the only thing is that we need to integrate it with the solar energy, and this is the final step of hydrogen production, where we carry out the reaction into copper, but copper plus HCl gives H2 and CuCl. Definitely collection was one of the major issue, but still we could do some. So now we need to integrate this whole concept of producing hydrogen from a water using a copper chlorine cycle with a 5-step process, and again using solar energy. So for that, again just your device, and you can see here, because of like when I started, I was not sure how we can achieve the desired reaction. After literature, so we can come to this. Fresnel lens is one of the application, because if we look at it, the availability of magnifying glass, that is very small. We can have hardly maximum 10 centimeter, or maybe 15-20 centimeter maximum, I think, available of the magnifying glass in the market. If we go for fabrication of very large scale, maybe 1 feet, maybe 2 feet, or something like that, then it cost is going to be extremely high, which is not or even not available. So when I was searching for the Fresnel lens, then I come to know that like we used to have overhead projectors in olden days. Nowadays, definitely we are using LCD projector. But in previous days, we used to have that slides that we need to project it on the whiteboard. So that OHP has this Fresnel lens, right? So one such OHP was available in Nirma, and that's I utilize it with the permission of definitely department. Use that Fresnel lens. It contains two Fresnel lenses, because that purpose is to magnify. If you put A4 size our slide, then it projects much larger, like almost 3 feet by 3 feet, or 4 feet by 4 feet white board. Fine. So that's what its purpose was, magnification. But here now I'm looking for I was doing in a reverse way. When I want to focal it, I want to achieve the focused on the center line. So I remove that magnifying glass. I utilize it for this chemical reaction purpose. Fine, and you can see here. So just for demonstration purpose, this is the thermocouple which I've attached, and this is what it shows me, almost 566 degrees centigrade I could achieve on the focal point with this magnification or with this particular Fresnel lens. So definitely the required temperature we can achieve it, but only the thing is the integration, how we can integrate it with the required setup. So again, I am saying this is not a success story. This is where we got failure in terms of we could not produce the final desired product in an economical way. But still, this is just to demonstrate that yes, we can do what we want. And if we go further, probably we may get success. Definitely, we need to put few more efforts. But that's definitely just I'm sharing this small parts. So this is how we devised Fresnel lens, which was available from the overhead projector OHP. Uh, and we have utilized it for the different applications. So almost practically we can say wherever possible, all the reactions we try to carry out using this solar energy. So we already carried out this all the reactions. We know the steps, we know the mechanisms, how to proceed it. Only the thing is that now we need to utilize it a solar energy, and that's why we have to repeat all the steps, fine, and all the reactions where we have carried out using this Fresnel lens. And I can say that definitely we have produced all the products which we have produced using electrical energy or conventional energy. Same products we could achieve when we got it using this conventional lens. And definitely electrolysis, we can definitely, it's easy that we can use a PV cell and we can convert it to electricity, and we can carry out electrolysis steps also. So some of the problems which I mentioned, just the problems in the experimentation part, what we have found. So one of the major, definitely I mentioned that relatively probably less hazardous chemicals, but still HCl handling by itself is highly corrosive. Fine intermediate products, copper chlorine at high temperature, it becomes a corrosive in nature. So leakage, material of construction, this is one of the major reason, one of the major problems we face when we go for the large scale productions. So at the decomposition steps at high temperature above the melting point of copper chlorine gas formation, and also the copper oxide formation occurs, which is not desired product. Fine. As such, theoretically we feel that okay, when we carry out a decomposition, there is only one desired product, but it is not the case. So many different products formation takes place with a different composition, and that's why to achieve the desired selectivity is a big issue. And copper oxide form which is not desired in a decomposition process. So once if it is copper oxide form, then it is not a useful product. We need to throw out, means it cannot be recycled in the main process. In electrolysis process, definitely collection of the gases. Definitely one of the major step of electrolysis is just to produce copper, but like a 3-step cycle or 4-step cycle, they integrate hydrogen production step with the electrolysis also. So like if you want to produce hydrogen, I mean hydrogen collection is one big issue. Definitely is that as a separate process also. And second observation is that these electrodes which we have used, like a platinum electrodes or graphite electrodes. So cleaning of platinum electrode is also difficult because of deposition of copper. Because copper gets deposited on the platinum, and once it is get deposited, removal is a big task. Hydrogen production steps, material of construction of a reactor as a reaction is highly corrosive in nature because it involves HCl, Cu plus HCl. So HCl and vapor phase, and at that to high temperature. So it is highly corrosive in nature. Find issues with related to gas collection and storage system. Definitely we need to handle hydrogen. What we have done, we used to collect the hydrogen under the pool of liquid, like we have simple submergence cases. So as the gas generates, it goes to the pool of liquid, and then it pushes the liquid down, and you can measure how much amount of hydrogen is hydrogen was collected, and that's what shows. And we have put a one outlet valve. When we open it, and we can ignite it, so we can assure that yes, there is a flame of hydrogen. Definitely quantity produced was very less, but just make sure that yes, product was there, but efficiency was not there. So very less conversion and separation of unreacted material from the reaction, because I mentioned that there are in different steps few solid handling comes in a picture. So that's why whenever raw material and product both are solid phase, then separation is a big issue, and that's what unreacted raw material is separation from the product is a big problem. Unreacted copper deposited on the reactor wall, it's quite difficult to remove it during electrolysis as well as even during copper hydroxide cycle. Uh, Fresnel lens, like I mentioned that this is what I have used for the OH pivot. Later on, I could find much larger Fresnel lens. I mean, this is a very interesting one. So this Fresnel lens is of the size of 88.4 centimeter, and it's quite big. OHP is hardly 1 feet or less than that, hardly like a 12 inch, hardly 10 inch by 10 inch or 12 inch by 10 inch, something like that. But this is almost 8 times bigger, 88 centimeter. It's huge Fresnel lens, and that too I collected it from the projector TV. Very olden days, they used to have a projector TV, we have now LCD TV. So at that time, that projection TVs are there, and from that one from scrap TV, I have collected this Fresnel lens. That was very efficient, very fantastic design, because it's very interesting. So I could achieve this. I collected this Fresnel lens from such waste material, and then I have through another project I have just designed and gets fabricated this two-axis tracking. Now, what is the problem with the solar energy when we work? That we know that sun is moving on a continuous basis. Practically every second, it changes its position. So what happens when we fix a location? Definitely, when you focus, like that is one of the reason that all the flat collectors have a poor efficiency, because we cannot track the sun. So in my case, I need to maintain the focus fine at one particular location. So now, if even whatever the best efficient system I have, if one sun changes its position, and if I keep my system as it is not going to work. Fine, so I must have to make sure that as the sun changes its position, I must also change the orientation of this Fresnel lens in such a way that my focus should remain on the same location. Fine. So with reference to that, this two-axis tracking comes in a picture. Two-axis tracking, why it is? Because we need to move horizontally as well as vertically. Fine. So both the way we need to track, because sun is not moving in a specific, it moves in horizons as well as vertical and horizontal directions slightly. And that's why this two-way axis tracking system was designed. Definitely, but uh, definitely I have put it, get it done through the commercial fabricator, get it fine. But still, my experience suggests that this is not giving me a 100% accurate results. Fine, because what happens, even slight change, fine, even 1 degree change in or 1 degree in efficiency may reduce in the result. Fine, so that's what the because and to you cannot make sure every second that you are going to be present over there. And so even though it is automatic design, it is a fully solar based system where tracking system, it's also utilize energy from the solar energy through PV cells. Fine, but because of the poor tracking, fine, um, I'm saying I'm getting 90% result, but there is no use of it. Even small change, 1 degree change may result in a poor temperature achievement. So that's why this is another problem which we face, that we need much better even efficiency in terms of two-way tracking system, most efficient, where we can utilize maybe some microprocessor base, which assures that even there is no deviation of even less than 1 degree, probably even much lesser than that, so that we can make sure that the focus is there, and whatever point we have designed, that is always focused, and we can achieve the required temperature. Fine. So this is what just I've shared. What the work which I have carried out. Fine. So these are the few things. And hydrogen production from water using the solar energy can be a feasible option. Definitely, I'm not saying it is impossible. And lots of research is going on, and many researchers are already working in this direction. When I was in university in 2000, almost 8, at that time project was started, and almost this project was continued even probably 2016, 17, like 10 years, more than 10 years. Fine. So what I'm trying to say that yes, like copper chlorine cycle or sulfur cycle or any other cycle, any thermochemical cycle to produce hydrogen from water is definitely technically feasible. Fine, people are working. Only the thing is that how to make it economically viable, or even electrolysis process. Why electrolysis process going to be feasible? Definitely, PV cell technology becomes more and more cheaper. Still, I'm saying that PV cell itself is definitely highly costly. But if I am able to, I'm comfortable that we can use a large PV cell park. Fine, in one remote places like any desert, and we produce sufficient amount of large quantity of hydrogen fine as a chemical fuel, and we can transport it to the different applications or different vehicles at different cities, then definitely it is going to be economically viable. Fine. I have just shared this one diagram from one recent paper which I come across, fine, where they have proposed one such thought process where they have utilized. Definitely, you can see the complexity of the process involved in it. Definitely, and they've used heliostat. You might have come across this heliostat where there's again a flat solar collectors only, but they move it in such a way that they put it, the all the energy is received at the this particular tower, and the temperature which can be achieved through this technology is around 400 degrees centigrade, something like that. And so that's what they have proposed. This, I'm not, my intention is not to make it complicated, but just only purpose is that yes, people are working in this direction, and hydrogen production from water using solar energy or renewable energy can be a feasible option. Definitely, research is still going on. People are working in this direction, and we are hopeful that definitely down the line in coming years we may come up with the hydrogen as a fuel, as a economical as well as economical, it means ecological source of energy. Fine. One of the, and one more challenge which we need to address, definitely we can't, uh, even if we produce hydrogen economically, then second major problem is the transportation and storage. Fine, definitely because of hydrogen is the lightest molecule. Fine, in a periodic table, H is the first atom, so it's the lightest. So another problem is how we can increase its energy density. So we need to increase either like we can store it in the like a CNG. We can use high pressurized cylinders, but because of properties of hydrogen, we need a very high pressure. Fine, extremely high pressure system is required, which is not make it economically viable, because as we increase the pressure, definitely thickness of the cell storage vessel increases, and thickness increases, definitely weight and masses increases. So which is going to be one of the major problem. If we go for liquefaction, then cryogenics, so again temperature achievement and maintaining that temperature is a big challenge. And third, more basically where research is going on, that is some combination, that is a solid material based storage, where like metal hydrides fine are one of the feasible options, where uh, reaction combination and it is reversible. Fine, so we can absorb hydrogen on a certain metal complex. We can store it, definitely not at room temperature. It is going to be high pressure, but not as high as with this, like a simple gas high pressure storage. So we can store it at reasonably high pressure, and we can release it. We can, like, it becomes reversible very easily at a, just by releasing it, and we can get the hydrogen wherever we require. So people are working in the direction also. So again, storage and transportation is another big challenge, and again separate research when different researchers are working separately in this direction also. So definitely in hydrogen production, there are going to be lots of challenges. And these are the few statistics in terms of transportation and storage. So this is what is expected. Definitely, I have just taken data 2 days back only. Definitely, but this data is very old. Fine, technologies have changed substantially, but still it is not very economical. That's what. Fine. So somebody we can say that a previous copper chlorine cycle which I have discussed, where I have started with any redox reactions basically, but redox reactions where zinc oxide reduction at a much higher temperature which is taking place. So it is not possible. So we need to go for any feasible option. That is, feasible options comes through the different thermochemical cycle. It either maybe a copper chlorine or a iodine sulfur cycle, etc. Where temperature is achievable, maybe 550, maybe 600, 700, 800, something like that. Fine. So copper chlorine cycle is possible. In this particular today's talk, I'll try to demonstrate that yes, we can also produce hydrogen using a copper chlorine cycle. But yes, definitely there are different challenges in each and every steps, and we need to put probably more efforts, more systematic efforts, and more scientific design way in such a way that probably we can find out the solution. And definitely solar energy utilization mentioned as one of the best option available. Fine. And using a proper tracking system, two-way tracking system, is another challenging aspects. Fine. So I would like to thank, definitely I have carried out this work with the help of Guj Coast financial support during the year 2014 to 16, and in my university minor research project work also done thanks to Myanmar management. So thank you very much to all of you for your presence hearing, and now we can have this session is open for any discussion or any question or any suggestion.
Any question from audience?
Probably I may go a little bit more theoretical in terms of, but I tried to share the few small piece of work which I have carried out. And definitely hydrogen is a very interesting molecule and very green, definitely, in terms of its final products.
Hello.
Hello.
Hello, sir. Rahul Prajapati from BBC Valsad, sir.
Yes.
Sir, as hydrogen is right now, hydrogen is emerging as a reactant in the various industrial sector for the chemical to synthesize the various chemicals. But the issue is that the handling of the hydrogen, sir. So,
Yes.
can we use the light generation hydrogen, the process they said, can we optimize such kind of process for the various purposes of that thing?
Just a minute, may I repeat your question that hydrogen handling is an issue and
Yes, sir.
live production of hydrogen?
Safety and handling is the major issue for the hydrogen, sir. So
Absolutely.
when we use for the hydrogen as a raw material for the various reactions, so this is the biggest issue due to that reason people trying to avoid hydrogen is used for the various reactions. So can we optimize such kind of issues by applying some various techniques and processes?
Actually, some other voice is there. So again, what I have understood, you want to say that hydrogen handling is an issue. So can we optimize the hydrogen, live hydrogen production?
Yes, sir.
Right. So definitely like live hydrogen production, wherever your application, what is your application desired? For what purpose you want to produce hydrogen? For reaction purpose or some other?
Sir, my hydrogen as a, actually I gone through the various studies. There are a lot of research has published based on that hydrogen used as a raw material. But
Yes.
all the literature has cited a one common notation that it is safety and handling is the biggest issue for the hydrogen.
Yes. True.
So there is an alternative way we can use the hydrogen directly, मतलब live hydrogen, which have the मतलब, good purity value with respect to the reaction, sir.
Definitely, that's what it like. If you look at it, the fuel cell, just with reference to your question only, but like fuel cell is one of the most successful aspect. Fine, but the thing is that how we can get fuel cell from where raw material is coming from. So if you use like a methanol to produce hydrogen, because we cannot store hydrogen, so that's why they propose that methanol can be produced, and from methanol we can generate hydrogen. Fine. So any such things which like what you are saying, we can produce live hydrogen and we can utilize wherever it is required. Fine. But the question is that how we can produce this hydrogen?
Uh,
Hello.
sir,
Is it?
yes, sir. Yes, yes.
So you like that. So like if I want to produce hydrogen, whatever different technologies I have, like people are saying for fuel cell we can use methanol, but methanol itself is so costly. If I go from hydrogen production from methanol, then definitely it is not going to be economically viable. Second live option is like electrolysis is the most even though I have discussed copper chlorine cycle, but it's more complicated. Fine. So most easiest way is like a electrolysis process where we can produce live hydrogen. But the thing is that energy involved in the whole process, fine, is so high that it is not making it favorable. And that's why if we are able to produce PV cell technology in such a way that it makes us solar energy available at much cheaper cost, fine. And apart from that, other issues of putting a pressurized hydrogen. If we can do that, definitely it is possible. So where we produce live hydrogen wherever I require and whatever quantity may require. Hopefully I could answer your question.
Yes, sir. Yes, sir. And I said other literature when I gone through it, there is a one possibilities of the ammonia generation. The wastewater is there. Like
Okay.
ammonia plant wastewater have the capacity to generate the hydrogen gas using the fuel cell.
Okay.
Uh, can
Fine.
can it is the मतलब, it is viable, economical viable, sir?
I have not come across like what you are saying that ammonia wastewater and from that we can produce
Like
hydrogen.
if any company is preparing मतलब synthesis the ammonia for the various purposes like NHC wastewater, the मतलब urea wastewater, NHC wastewater, these
Okay.
wastewater have the higher hydrogen value compared
Okay.
to the other regular water, मतलब that
Fine.
wastewater. So as
Fine.
to recover the like of like, if we going to use the fuel cell, so again due to some wastewater characteristic, due to the wastewater we will not able to utilize that thing. So my
Fine.
question is that such kind of fuel cell are there so that we can use such to generate the hydrogen from the wastewater, sir.
Okay. Yeah, that the concept wise looks very good. Fine. That we can remove the whatever pollutants are there in the wastewater, and we can convert it into because it contains a large amount of hydrogen molecules. Fine, like ammonia and other aminical. Fine. So definitely concept wise is very good, but I have not personally come across any such. But definitely, ultimately, I'm saying it's a very simple logic. If we can trade the water again, water economy is going to be more costlier over the days, so we can remove the pollutant and at the same time we are recycling water, that is beneficial. And if we can produce hydrogen, definitely it is going to be added advantage, definitely. But need to check with the feasibility in terms of technical aspects and definitely economic. Personally, I have not come across, sorry, so I am not able to comment that yes it is economically viable or not, but definitely concept wise is good.
Okay, sir. Okay, sir. Thank you very much, sir.
Anyone else from audience?
Sir,
Hello.
sir, you can give some insights on this, sir, chemical hydrides systems which is used for storage of uh, this hydrogen which we have produced, sir.
Yes, it is very interesting field, but I mentioned that it's a completely separate research work. I personally have not worked in that direction. Definitely chemical hydrides. What I've understood, like it's a complex molecule, fine, where it's a we can it's acts as a absorbent as well as it carries out some chemical reactions, fine. Again, I'm saying that I'm not personally gone through any details of that, but I've understood that simply that because of there is a chemical bond which absorbs. It's not a simple physics option, fine, it's going to be chemistry option. where it it can absorb large amount of hydrogen, definitely at a little bit higher working pressure, and we can release it, and it's completely reversible also. Fine. So people are working, like if you check it out on the literature survey, that people are working on a different such materials where we can get maximum amount of hydrogen, because ultimately objective is that with the smallest amount of weight, fine, I need to increase the hydrogen density. With the smallest amount of adsorbent, I can get maximum amount of hydrogen. Fine. So that is a completely different research work, and people are working. But unfortunately, sorry, I don't know much about it. Hello.
Yes, sir. Yes, sir. Bharat, I think clear to you.
Yes, madam. Yes,
Yes.
madam. That is a different area for storaging of this hydrogen. It is also a different research area. Yes.
Yeah.
We are at the end of the session. Thank you,
Okay.
sir.
Sir, I have one question. I'm Chirag Tamboli from GC Valsad.
Yes.
Sir, I just want to ask you that as we are seeing that hydrogen as a future fuel,
Yes.
but are there any conventional or normal techniques by which we can identify the any leakage or any accidental leakage of the hydrogen, such as in case of LPG by smelling, we can say that it is such kind of leakage is there. So as we are seeing it for a future fuel, so is there any normal some techniques or conventional techniques by which we can identify that the leakage or
Yeah,
some
definitely.
kind of accidents are there?
Definitely means we can try when we put it in a commercial aspect. Definitely, we have to think of it. It is one of the important aspects, because if it gets leakage in
Sir,
a closed
your
environment.
voice is not properly audible.
Hello, hello. It's audible
Hello.
now. Hello.
Yes, sir. Yes, sir. You
Yes.
are audible now.
I think
Yes, sir.
someone else audio is on. Okay, so just what I was telling. Yes, definitely it's a very critical issue. Okay, when hydrogen gets leaked, and in that too in a closed environment, it is difficult because it does not smell, or we can't detect it so easily. So definitely we may have to work with some kind of based on the smell basis, like we are adding mercaptans today nowadays for LPG cylinder, or some other devices or some sensors where it can sense it. Fine, but right now I'm not exactly means there is no practical aspects right now available. Fine, but definitely when we put it in a commercial way, we need to have some such kind of detection where we can detect it very easily, and we can stop it if any leakage is there.
Okay, sir. Thank you, sir.
Sir, sir, other than sir, this higher temperature is required in the reaction phase. Sir, other than this problem, any other sir major problems, major engineering problems involved in hydrogen production, sir? This very much high temperature, rather than this point, sir.
No, like if you look at it, all the thermochemical cycle, like if you go for two steps process, lesser the steps, high is the temperature. Fine, that is one thing. Fine, like in zinc oxide, it's 2000 degrees. If we check it out, different cycles, then the temperature, if you come down, then number of steps are increasing. Now, as the number of steps increases, not only the temperature is reducing, but at the same time, its complexity increases. Fine, just I've explained that copper chlorine cycle where not only like it's a 5-step process, but it also involves handling of the HCl as a gaseous form, different solids, and its mixture of solids comes in a picture. So this makes the whole problem little bit complicated. But yes, definitely we can solve it through a proper technological way. Fine, but need to put in a proper efforts. Otherwise, definitely, uh, people have produced hydrogen at lab scale, and with the successful, definitely with the whole complete cycle, with the complete recovery of all the intermediate products. But definitely these are the only issues Apart from the temperature, that is the handling of the corrosive materials and handling of the different mixtures of solids, and its separation comes in a picture. But yes, it can be solved with the proper technology. So we need to trade off whether we want to go for a high temperature or we need to go for a more complicated, lesser temperature but more complicated processes. So challenges are there both the sides.
Thank you, sir. Sir has very well discussed about current sources of hydrogen, limitations of current sources of hydrogen, redox reactions, copper chlorine cycle, hydrogen production by copper chlorine cycle using solar energy, clean source of energy, which is, and hydrogen storage. Thank you very much, sir, for such an informative session. Thank you for being with us, accepting our invitation, and delivering excellent.
Thank you very much for giving me an opportunity. Thank you.
Thank you, sir. Thank you for your accepting our invitation.
Thank you, sir. Thank you very much.
We end the session over here. Okay, sir. We'll meet tomorrow, same time, for the tomorrow's session.